Okay, so we're on example 6 right here. Excuse me, this is the very last thing we didn't get to yesterday. In your assignment, this is numbers 7 to 10. It is saying verify in the direction. It's saying verify, and when we see the words verify in math, that usually means some sort of proof, like show every single step. Like a proof type thing. And to verify algebraically that these are actually inverses, we have to do, we have to show that f of g of x equals x, and we have to show that g of f of x equals x. Which is kind of confusing, but this is basically saying for the f function, which I'm going to make blue, for the f function, wherever I see an x, I'm going to replace that x with g of x. So wherever I see an x in the f function, I'm going to replace it with g of x. So my f function, every time I write it, it's going to be blue, so you can kind of follow which equation I'm talking about. And then my g function, I'm going to write in red. So over here, I have to show that g of f of x is also equal to x. So what I'm going to do is I'm going to put the g equation into the f equation and simplify it and show that it simplifies to x. So that's me showing you work. So let's start here. F of g of x is equal to, so now I'm going to put one of them inside the other. I'm going to take the f equation, which is 3x minus 1, and wherever I see an x, I'm going to put in g of x. So I'm doing 3 parentheses g of x minus 1. G of x is x plus 1 over 3. So I'm putting the g of x inside of the f of x equation instead of x. And then I simplify. So I will, let's see, multiply 3 times a fraction. I put 3 over 1 and I go straight across. And if I'm multiplying 3 and at the same time dividing by 3, what happens to multiplication by 3 and divide by 3? Cancel, so we get x plus 1 minus 1. And then from there, I'm going to simplify one step further. I'm going to say, well, 1 minus 1, 0, so x. And there, I have showed that it equals x. So you have to show that with steps. You can't just write equals x. Like, you have to show your steps. And then you have to do it a second time. Sometimes people will make like a silly mistake in math, and one of them will work and one of them won't. That can't happen. They both work or they both don't. So we're going to do both f of g of x and we're going to do g of f of x. So this means I'm going to take the g equation and I'm going to put f of x inside where the x was. So my g equation, my x was up on top, plus 1 over 3. So instead of x, I'm going to put in the f, which is 3x minus 1. And then I would just simplify. So I have 3x minus 1 plus 1 on top. Order of operations, going to do the top first. So we get 3x over 3. Then I divide 3 by 3 and I get x. So that works. So that's how you algebraically verify that they are inverses. So that's what 7 through 10 looks like. So if you get it, you're more than welcome to work on it. I'm going to walk through the next 2 examples so that they are recorded. So if you'd like to walk through the next 2 with me, you can. If not, that's up to you. So this is the same way we're going to do f of g of x. And my f equation is 8, and my x becomes the parenthesis cubed. So wherever I see the x, I'm going to replace it with g of x, which is cube root of 2x. And then we have to think about our radical rules from Algebra 2 to simplify that. If I have a cube root and I'm cubing it, those will undo each other and I'll just get 2x. And then I multiply these together and I get 16x. Does that equal x? So what I can say is these are not inverses. But just in case I made a silly mathematical error, I'm going to do g of f of x as well, because neither of them should work. If one of them does and one of them doesn't, I'm doing something wrong. So now I'm going to do g of f of x, which says take the g equation, and wherever you see an x, make a parenthesis and put in f of x. So underneath my cube root, I'm going to multiply this stuff together, get 16x to the third. And then I'm going to use radical rules from Algebra 2 that some of us may or may not remember very well. I'm going to have to review it at some point. And when I simplify that, I get 2x cube root of x, which is certainly not x, which I'm trying to get to. It's definitely not x. These are not inverses. Does not equal x. And then I'll work through that last one. Again, we're just putting one equation in place of x in the other equation. Both cases. F of g of x. So wherever I see the x, I'm going to replace that with g of x. I put parentheses around where the x was. I'll put in cube root positive x plus. Remember when you are cubing a cube root and the cube cancel each other out, and I bring everything else down. Negative parenthesis, I have negative x plus 4. Plus 4. And then because I have that negative outside of the parentheses, that's going to change all my signs. So again, positive x minus 4 plus 4, which gives me x, and I verified f of g of x. So now I'll go verify g of f of x. I take my g equation, and wherever I see an x, I'm running out of space, sorry, I'm going to put in the f equation. I still use those parentheses to replace that x so I don't do any silly mathematical errors, because here I'm going to have to distribute that minus sign to give me positive x cubed minus 4 plus 4, which is going to give me cube root x cubed, which is x, yay, it's verified. So like I said, if you get one that works and one that doesn't, you're making some sort of mathematical error. And then you would want to come and ask me about that before we grade it tomorrow. Okay? So your assignment is 1 through 10. You should have already had a little bit of time to work on 1 through 6 in class when you got done with your quiz. 1 through 10 is the whole assignment. 7 through 10, you're doing this way. All right?